Let's get a little more volume here. Hi, everybody. Hello. Hi. So we're off to a mostly on-time start. Sorry about the slight delay. Who knew that I needed a physical key to get into this thing? Yeah. Well, hello. Do some deep breathing. I'm back. I'm 100%, I think. Yay. Yeah, that was not super fun. Thanks, everyone, for your patience. It definitely was a bummer. I was bummed not to be here on Wednesday, but I think it was definitely for the best. What I wanted to do today was I wanted to spend a little bit of time kind of reviewing some of the stuff we talked about over video. Recording, that's good. Good news. But I also wanted to take a couple minutes at the top of class to answer your questions, if you have any questions about Rhino and the upcoming assignments. So I'm kind of going to put it out there. Yeah, hi.
Is there a way to know how many blocks you have that you created without having to work on your side?
Yes, there is. Let me show you. So this would be a good time for me to just go ahead and open up Rhino. Any other questions while I'm waiting for Rhino to open? Okay. That's a fantastic question, though, and it's very catered to the mini assignment. So I am usually, sometimes people ask me, like, oh, should I always update? And I would say that depends. Right now, I'm really busy, so I'm not going to update because it's a distraction. In general, I do try to keep my software updated. The sole exception to that is if I'm developing like a really complex project, like a game project, because what worked in one version might not always work in the other, and you sometimes have to make changes. So it kind of depends on where I'm at in my production process. If we have a couple seconds, I do have a very short update video. But let me go ahead and just open up a new file. This was for some signage for my lab. I was doing these carved wooden signs. That was fun. And there should be this new document here. So I'm just going to drop a couple of boxes down on the thingy, on the canvas. And I'm going to then just move them around. Control-C, Control-V. So basically what I want to show you is no matter how many objects you have in Rhino, and let's say you have quite a few, when you select multiple objects in Rhino, it does give you kind of a report at the bottom here that says 8 extrusions added to selection. So if, for example, you've gone ahead and you've grouped these, the way to kind of get that count, let me go ahead and show you how to group them. So the group is over here. We'll review all this stuff later. Now when you select it, it still says 8 extrusions. Sometimes it will actually say 1 group or 2 groups. And if you really want to know like how many specific objects, you can just ungroup it. Yeah. So that's basically how that works. Any other questions before we kind of jump? Yeah, hi. Where? Because probably there is, if we go to, well, first of all, I'm going to ungroup this so I can address these individually. I'm guessing that there's probably some hidden objects. In other words, there might be 2 objects that are on top of one another. That would be my guess. So here, you can see this has 2, and then this one probably has 2 as well. Yeah, it's a good question, though, given the circumstances. I can only count to like maybe 10 or 12, you know, so I need the software to do it for me. Anyone else? Okay. Awesome. So basically, one of the things that I wanted to talk to you about today, I wanted to start off with a few slides, and these are not like fancy slides, they're just slides that kind of get the job done. I want to kind of step back for just a tiny bit, for a few minutes, before we kind of get into actually doing stuff with Rhino again. And I want to talk to you about how Rhino kind of fits into the world of 3D design tools and why you would or wouldn't want to use Rhino for your next creative project, whatever that might be. And I also want to talk a little bit about, just a teeny weeny, like one slide about the history of these 3D modeling tools. So basically, in the 3D modeling universe, there are probably, I don't think I'm exaggerating when I say there are hundreds of software tools that allow you to model 3D objects. Some of them are code-based, some of them are, you know, based in a graphical user interface like Rhino. And some of them are better at doing some things than others. So probably, I would say there are 3 main classes. So I have 4 listed here. The surface subdivision modeling is something that is pretty exotic, and it's only of interest to like people who are really into like mathematicians and people who are kind of exploring interesting topographies. And so it tends to be a little bit more of like a kind of scientific way of going about modeling. The tool that we're using right now is what's called a NURBS tool, and we're going to talk about NURBS at length. But we haven't really, up to this point, gotten a lot of exposure to vector-based tools in this class. But if you're studying graphic design, congratulations. Probably all of the tools you're using are vector-based tools, like Adobe InDesign or Adobe Illustrator. Those are probably the top 2 vector-based tools that are out there right now. There's an open source version of a vector-based drawing program called Inkscape that's quite good if you're an open source software person. And then Autodesk also has lots of sort of like down market like apps. And I say down market because Autodesk is traditionally like the sort of software of architects and high-end engineering applications and things like that. So for Autodesk to make like a software tool that's geared towards lay people is actually kind of a big deal. And they have several now. So the important thing is not maybe to know like, you know, what vectors are. I mean, we talked about them a little bit in the sort of intro lecture about digital images. And to say it sort of real, you know, succinctly, let me see. Yes, I can draw on the board, and people will see me. That's nice. So the important part to know about vectors is that they're really just describing a line between 2 points, right? And that line could be curved or it could be straight. In any case, they're kind of like the anti-pixels, right? They're not operating on a grid. They're operating on a completely different system of geometry. It is true that it's based on a Cartesian grid, but believe it or not, there are even some modelers that work on different coordinate systems, like polar coordinates, if you're that big of a nerd. For our purposes, the reason that we are using a NURBS tool, and I think NURBS tools tend to be, this is a bold claim, but I can stand by it. NURBS tools tend to be better modelers. And some of the other packages that you might see under polygonal modeling, for example, those tend to be sort of cinematic effects driven. So they're really driven towards what? Speed and being able to have like the most polygons. you know, it's like you take your polygons to your monster truck rally and, you know, drop them off on the side, maybe. So polygonal modeling is a thing, and it's really important. It's what's sort of prevalent in the effects industry. But outside of effects, polygons are not really the best way to describe, like, normal reality. Why? Well, because, I mean, we can see just on a casual inspection, like, if this object were translated to polygons, it would be fundamentally different, right? Like, it would be fundamentally changed. You wouldn't see these, like, nice curves. You'd see the, like, jagged sort of edges, probably. So we're going to do a little bit of, like, comparison and contrast today of, like, what polygons look like versus what NURBS looks like. It's a very, very important distinction. It's almost as important as the distinction between the pixel and the vector. And NURBS are really just like a fancy way of saying vectors in 3D. They're called, this is where it gets kind of historical, they're called non-uniform rational B-splines. And that actually comes from the world of shipbuilding. And so the last category of sort of objects and 3D modeling sort of logic that we have here is constructive solid geometry. So if any of you are using a package over with your fancy engineering license called SolidWorks, that is a really great example of constructive solid geometry. That's why, incidentally, that's why it's called SolidWorks. And then another example is also AutoCAD, just straight up Autodesk AutoCAD, which is like the leading package for architecture. Now, it's not to say that some of these packages or some of these software tools can't talk to each other. They can. And just like most people, you know, your workflow as a digital artist probably involves more than one software package, right? I think the important part is just to kind of like know some of these basic concepts so that you can make educated choices about where you want to start and maybe what you want to do after that. So NURBS are really, as I sort of pointed out before, NURBS are really just vectors that are existing in three-dimensional space. So if you, for example, if I were to code a vector, or a vector line in like P5, which we'll be doing right after this, all I would have to do is take this curve right here, and maybe if I were to rotate that curve in 3D space, like on the y-axis maybe, I would have a three-dimensional shape that could potentially be 3D printable. So for certain tools, that distinction between 2D and 3D can be really kind of like very fine. But for this sort of unit, we're really going to be focusing on three-dimensional shapes in Rhino. Although if you did need to produce a two-dimensional engineering drawing, Rhino's a great tool for that too. So as I said before, like, you know, taking a vector and then sort of distributing it in three-dimensional space can result in a three-dimensional form. There's also this sort of like kind of pro and con angle to whether you're using NURBS or whether you're using polygons. So right now, like, I'm actually working in a game environment, and so I am working in polygons. There is not a single thing in that environment that is NURBS made. Except some of the more complex objects are objects that I modeled in Rhino, but then I converted to polygons so that they could be usable in a game environment. So that is actually a super common workflow because there are certain things in polygon modelers that you just can't do, and you can only do them in Rhino. So I made that decision for a couple of things. I think personally NURBS are really good for anything that's biomorphic or anything that has curved lines. I mean, that kind of just is common sense. Like, if something's polygonal, it's going to maybe fall down a little bit when you have really gentle curves. Polygons, however, are really great for games. They're really good for cinematic effects. They're great for 3D scans where you need a lot of data and a lot of detail. And they're also really good as a sort of final format for 3D printing. And in fact, as far as I know, there's no 3D printer on the market that will work from a NURBS file. So that's sort of an essential part of 3D printing, is converting your file to polygons. So yeah, and can you make polygons from a NURBS model? We are going to do it in a very short second here. So if we think about this sort of like hierarchy of form in Rhino, I can sort of walk you through that. I think that would be a good place to start with Rhino. And then I also think that we can talk about some other issues related to NURBS and polygons. And so this is sort of like starting to get into things that will be relevant to the Impossible Object project, but this is also just a chance for me to kind of like show you in real time, in real life, what is the difference between NURBS and polygons. Because like I said, it's sort of like a really important distinction. So I'm going to just make a form in Rhino, and I'm going to make a quick form. So I'm going to do something that we probably haven't done before. Well, I'll go ahead and start with this hierarchy. So we have this, and this should be a little bit of a review. We can make a line by just clicking on the polyline and entering out. And then obviously, like one sort of step more than that is a closed polyline, which, by the way, it's important that this is closed, because if it weren't closed, we wouldn't be able to then convert it into a surface. So I'm going to go ahead and use a surface creation method, which I'm pretty sure that we have not done. I just watched through the video from the before times, and I'm pretty sure we haven't done this. So basically what I'm going to do is I'm going to go to planar curves, which should work for any set of curves, any set of closed curves that are planar. What does it mean that they're planar? It means they have to literally be on the same plane. They have to be flat. There are other curve methods for curves that are not planar, but now we basically have a surface. And you can see what happened with this surface. I'm going to cut and paste it before I kind of do other stuff with it. When we selected this surface, you could see it had 4 points around it. Those are called edit points, and you can bring them back by clicking over here, Show Object Control Points. And then you can grab one of these, and you can select the surface point, and then you can start to get things a little bit weird, if you wanted to. Useful thing to do. You could also potentially, do 2 at once, right? So that then it looks like the entire thing is, moving in a direction. Obviously, right now, it would probably be better to not have my object snaps turned on, because it's snapping to that thing underneath it. Not important. Anyway, so now I have this certain surface, and sort of the next step forward in the hierarchy of Rhino form is to go to a poly surface. And so there's a couple of ways to get us to a poly surface. I'm going to go ahead and duplicate this one more time, because I just want to show you the difference here. So a poly surface is basically if we were to take this surface and we were to extrude it into space. So it's going to result in something that's not super exciting. It's going to be a cube. But let's go over here to the surface menu, and let's actually, let's do the solid menu and extrude surface straight. And so what that allows you to do is it just allows you to put like a height on the object. One thing that I'm going to do now that I'm getting into kind of solid form is I'm going to just double tap on some unoccupied area of the screen. And I'm going to choose a ghosted viewport because I just want a little bit more information about what's happening here. And so, yeah, that's great. So here's our extrusion, a polysurface. Sometimes Rhino will pop up and say, oh, this is an extrusion, and you might ask yourself, what's the difference between an extrusion and a polysurface? There really is none that I can tell, like no actual difference. But for some reason, Rhino sees fit to call it different things. So that's basically how you make a polysurface. And so then from there, you can also, if we were to, let's say, extrude this surface straight again, I want to show you just real quickly like what the difference is between a polysurface and a solid. So right now, I'm going to take this small form here, this polysurface, and I'm going to hit the explode button. I personally love a software tool that has a good explode button. Makes me feel good. So so I exploded it, and so what that does is it basically breaks it up into its constituent surfaces. And now I could take one of these surfaces and get rid of it. Now, what I need y'all to kind of pay attention to here is there's two things about these surfaces. These are both polysurfaces, strictly speaking. I can go ahead and join these back together by hitting the join button, and then it puts it back into a polysurface. Which one of these is going to be 3D printable and which one is not? Anybody? No? Okay. Well, to make something 3D printable, it has to have what's called a watertight shell. And so this surface right here, these surfaces on the side, literally have 0 dimension. A surface is like, I don't know, maybe you could think of it as like conceptual duct tape, right? Like it doesn't have any realness. If you cover up your basket with conceptual duct tape, the water is just going to run right through, right? So yeah, it's useful, and it looks like something on screen, like it displays as a thing, right? But it doesn't have any dimension. And so that's really like this, pretty much the most critical thing about 3D printing is that you have this so-called watertight shell. Now, 3D printing programs are getting a little bit better over the years about tolerating really bad geometry. In fact, the program that we use in the lab has a function, I kid you not, you check a box and it says, fix horrible. Yeah. So there's a lot that you can get away with, but in general, you're not supposed to 3D print objects that don't have like a sort of physical scale or a physical mass. So I'm going to try another little method here to create an object, just because we're sort of like trying to bust into some of these features of Rhino that are a little more advanced than creating these polygon primitives. So I'm going to go ahead and create a Bezier curve or a control point curve. And the control point curve can be a little tricky to master. So I would personally, if I were doing this for the first time, and I haven't been doing it for 20 years, I would maybe practice for a tiny bit and just try making curves. So what I'm going to do is I'm going to start with an endpoint, and I'm on grid snap, so I guess I could snap it to the grid. I'm a big fan of the grid, in case you haven't noticed already. Now, common sense would tell you that if I click this point here, then the curve will go through that point, right? Common sense has no purpose here. So what that does is that creates an anchor point, and then the curve is like almost like magnetized to that point. So let's try clicking here, and then I'll click back here, and you can see that third point, the point that's the control point is just sort of like laying there. And then this point, I'll make a point here, and then I'll just make another control point like somewhere over here. And then somewhere over here. Now, here's my advice to you if you're making curves for the first time and you're totally intimidated by this process. Check it out. We can take this curve, and we can select it. And when we select it, lo and behold, it comes up with all the curve points highlighted. So my philosophy with curves in general is to sort of get through the curve, to get from the bottom to the top, in other words, or get sort of as far as I'm going to go. And you can change the points literally until you're like exhausted and ready to go home. So changing the points is definitely like probably a lot easier than making it out of the gate from scratch perfect, you know, all the time. But now I have a curve made, and it's just, you know, this is sort of like, I don't know what this would be. This would be like, maybe like the bottom of a lamp or something, I guess. So a curve does not necessarily make a three-dimensional object. So what I'm going to have to do is I'm going to have to make this into a three-dimensional shape. So probably what I'm going to do is I'll select this curve, and then I can go over here to, I can do actually from the solid or the surface menu, but I think I'm going to do it from the surface menu and do revolve. So the revolve is just when you want to take something and you want to make a form by rotating something on an axis. Now, in this case, kind of common sense would be to do it like you know, that would be the axis on which it would spin. Down here, you should be able to give it a start angle, and then you can click this full circle button, and that will basically just make it into a full revolution. Rotate rail, which was one of the other examples, is also, or rail revolve is a super awesome way of doing it too. Rail revolve is what happens if you have an object that's not perfectly circular and you want to basically take this curve and make it wobbly, right? Or you can even use like star patterns or whatever. There's so many things you can do with this type of creation. Now, hey, it seems like we made this pretty decent surface here, but it's got a couple of issues. If, for example, I did want to actually 3D print this, well, the issues would be that it has this beautiful surface that has, as I said before, literally like no dimension. So if we wanted to print this as a solid object, I would have to basically fill these holes on the top and bottom. So over here on the solid menu, there's this really great and really convenient thing called cap planar holes. And that basically just fills any flat hole you have, which is super, super helpful. And so, yeah, then I've got a sort of object that I can go ahead and use. Now, I'm going to show you all how to make sort of 3D printable files from this, but maybe one more thing I should do to this object, just because we're here and, you know, I'm here, we should do this. I have extra minutes. Let's go ahead and hollow this out. So it's common that you would want to make a shape that is hollow, right? So like if we wanted to turn this into a vase or a cup or, you know, something that's like, this looks like it would be a great coffee cup, you know? But in order to sort of hollow it out, it's not enough that I just delete this surface on the top, right? Because we've been through this, right? If I do that, then it's not solid, it has this paper-thin surface. So the thing to do in this case is to use a command called the shell command. And I'm actually just going to type it directly into the console because. And you can select faces to remove from the closed poly surface. OK, so I want to remove this top, what I think is the top right here. And then it asks you to select a thickness for the shell, and that would basically be what's called wall thickness. So for wall thickness, I'm thinking that it might be a little bit helpful for me to just double check what my units are. So it looks like that's 10 units, and so I think maybe a thickness of 2 would be right about where I'm heading. So now I'm going to go ahead and click Done. Whoops. That didn't go all so great. I'm going to check one thing real quickly. Nope. I'm just going to try it again and set my parameters a little bit differently. Okay, so yes, please, done. Okay, that's better. I must have just been a fluke. So now you can kind of see like what has happened here, that we have this object that is completely modeled on both sides, on the inside and on the outside. And so this is really what you would want a shape to look like if you wanted it to 3D print it, but also still be hollow. And some 3D printing programs are a little bit better now about automating that from a solid. But for the most part, if I were doing it, I would want to kind of control it myself and know exactly what I was getting. Okay, so that basically, brings us to this sort of like, I would say this is a done model. I mean, there's a lot of other things we could do to it, but for the purposes of today, I think it's fine. A lot of people ask me when I'm doing these demos, like, "Oh, Meg, why do you always like demo as if the top were the front?" And I guess all I have to say about that is that I'm special, and I often will just rotate things into place, So I don't really pay too much attention about whether things are in the top or the side or the bottom. Until I have something that has an actual orientation, it doesn't matter. So now I have these 2 units, and they're pretty much identical. So they are not just pretty much identical, they are exactly identical. So what I'm going to do is I'm going to take one of these, and I'm going to do a sort of version of the process that you would do if you wanted to make this into a 3D print, which is I would go to the mesh object, and I would say, hey, make a mesh from a NURBS object, which is exactly what I'm trying to do right now. And so here you get this like slider where we can make this literally with like all the polygons. In general, when you're 3D printing, having all the polygons is good, because then your 3D print is going to look the most like what you designed it to look like, right? Also, 3D printing is not necessarily a kind of environment where you have to put it on the screen like 60 to 120 times a second, right? I mean, you can see like in a gaming application, doing a high-resolution NURBS object would be like ridiculous. So for this, I would say more is better. Go with more. So now you can sort of see like how that mesh has sort of broken down. And in this case, I mean, these objects, it looks like a simple object, but to actually make a polygon mesh approximation of this, it's like the smoother it is, the more difficult it is for those to kind of like look exactly right. So let me go ahead and do the other one, and I'll do it at kind of a low quality mode. So I'm just going to take the polygons all the way down, and I could probably make this even worse if I wanted to, but this looks plenty bad. So I'm going to go ahead and just move my polysurface out of the way here. So you can see here like very clearly, and definitely if we go to just a rendered viewport, you should be able to see even more clearly. One of these things is not like the others, right? So this probably would be the type of polygon conversion that you would do if you wanted to insert it into a game environment, because, I mean, I try to get my performance and frame rate as high as possible. So I try not to overload scenes with geometry, but sometimes you kind of have to. And I think in general, like this type of smooth conversion just functions like a little bit better, as a representation of what we originally created. So again, it depends on what your concerns are and what sort of other environment you're putting this into. For the sort of purposes of this class, unless you're doing the bonus 3D printing assignment, you should be able to go ahead and do everything in NURBS, and this wouldn't be an issue. So let me make one more form before we head out for the day. And then I think on Wednesday, I think I'll get sort of into making geometry for our scene building. So what I'm going to do is I'm going to do a variation of what we did before. So I'm going to create a polygon. I'm going to use the star polygon because we're all stars. And I'm going to have this be like not really so star-like, because if you look at it right now, it's like, oh, that's interesting, that's very like gold star on your report kind of thing. No, that's not what we're doing, don't worry. I'm going to take it, and I think I'm going to make maybe like 30 sides. And I'll start out here. I'll make this fairly large and fairly deep. Okay, so basically I made sort of like some kind of crazy zigzag. And now what I'm going to do is I'm going to take that control point curve, and I'm going to use one of these points as a starting point. And in fact, it would be really, really nice if I could snap to the grid here and use this as a starting point. So I'm actually just going to rotate this a teeny weeny bit so that it lines up with the axis here. Wow. And so now I can start my curve here. And there's not like a really strong reason for doing that. Like, I just want it that way. So now I'm going to kind of basically make the very similar curve to what we made before, which is just kind of a slopey-dopey curve here. And now what I'm going to do with this curve is I'm going to use that rail revolve that we had talked about before. And I said, it's so awesome. And you were like, yeah, how awesome? And I was like, this awesome. So, all right, select my profile curve. My profile curve is going to be sort of the side curve, right? And that's actually, a lot of the terminology that's used in Rhino is a holdover from construction and woodworking, because that's, before Rhino, that was how people made stuff. So, yeah, it's this side curve. And then the rail curve is this bottom curve. And then it asks for a start and end of the axis. And so I think I'm just going to try to put that on this axis. And so you can see here what has happened. We sort of created this shape, but with like quite a lot more flair. But wait, there's more flair. And so one more thing I want to do to it, now that we have this sort of ripple flare happening, I think it would be pretty cool if we went over into the transform menu and twisted it up a little bit. So these transform commands like twist, bend, taper, and stretch are totally useful things that you can use on a poly surface. Probably they're the kinds of things that you want to do when you're a little bit further along with what you're making, because they only want to work on poly surfaces and that sort of thing. So you can't really pull a twist on a curve, for example, or that kind of thing. So okay, let's go ahead and twist it. I'm going to select the poly surface here to twist, and then it asks me for a start of the twist axis. I want that to be like dead in the center here. So, and then the end would be probably just on top of this. And then it's going to ask you to basically come up with an amount of twistage. And so that is just totally based on your own sort of personal preference. I would actually caution you maybe against over-twisting things because, I personally prefer them to look a little bit elegant. But yeah, anyway, you can see that that's what you get when you twist a thing. And now, this is still sort of not 3D printable, so could we come in here, this is sort of a question that I don't know the answer to, could we come in here and close these holes up? And actually, that might have been a good thing for me to think about doing before I twisted it, because now these shapes are, I'm going to just see if these holes are planar. I'm guessing that they probably are not. So I'm trying to use the cap planar holes. Oh, hey, look at that. Lucky me. So, yeah, so sometimes there's a certain order in which you have to do things, but yeah, it's definitely like a fun sort of exploration. I'm going to ask if anybody has any more sort of super fun questions. Yeah? Okay. I'm going to show you my little so I've been slowly making some progress on my game environment, and that's been, I have like a less than 1 minute movie. So I made like a subworld for my world. This was a couple weeks ago. This is not what, I didn't do anything while I was sick. But I did this, I was starting to get so bored. Oh yeah, that's my side world. So the idea is you can grab these islands and it'll stick you back on one of the islands. And then I guess the other thing I've been kind of working on, and this is a vector thing, in Adobe After Effects, I've been making these little animations like that sort of play in the space, and then they'll function as like little portal calls. Portals, or portals. See, this is the problem with portals. Once you start making portals, where do you end? You have to find a portal, see? All right, well, have a great couple of days. And on Wednesday, we'll sort of pick up with useful or potentially not useful stuff creation in Rhino.